This problem tells us to select all expressions that represent the volume of the rectangular prism, and so I start by counting the cubes along the length, 3, the width, 5, and the height, 4. Then, knowing that I can calculate the number of cubes, or the volume by performing length times width times height, I write out the expression 3 times 4 times 5. I see this expression in the list of multiple choice options, and select it. Next in the list is the expression 3 plus 4 plus 5. This is incorrect, because when finding volume, we must multiply, not add, to calculate the number of cubes that make up the prism. I now see 20 plus 20 plus 20 as an option. Although it's addition, it is repeated at addition, which means it is equal to 20 times 3. The group 5 times 4 equals 20, and this group is multiplied by 3, so it has the same meaning and value as 20 plus 20 plus 20. If we look at the expression another way, we can also find the volume by solving 15 times 4 by first solving 5 times 3 to get 15. However, 15 times 4 is not the same as 15 times 15 times 15 times 15. Finally, if we go back to our original expression, we can rearrange the factors to show 5 times 3 times 4. When we group 3 times 4, we can see that this expression is equivalent to 5 times 12. To find the volume of the figure, I start by breaking the figure into two rectangular prisms, then label them A and B. I begin organizing my information. I first have to find the volume of prism A, then the volume of prism B. I know to find the volume of a rectangular prism, I can use the formula, length times width times height. I can use this formula for both A and B. Now I have to find dimensions for prism A by counting the cubes along the length, the width, and the height. And I can do the same for the back prism, prism B. Now that I have all the correct dimensions for each prism, I simply have to solve each multiplication expression. The total volume of the figure can be found by adding the volume of prism A to the volume of prism B. We are asked to select all expressions that represent a way to fill the rectangular prism with layers of centimeter cubes for a base. A base is one layer that can be found by multiplying two dimensions together. One way to solve this problem is to write the volume formula, length times width times height. Then group the numbers in ways that can match the expressions in the multiple choice list. For example, if I group 5 times 6 in this expression, I can see it matches the multiple choice option 4 times 30. When I group 4 times 5 together instead, I can see it matches 6 times 20. I can also rearrange the numbers from the original expression to find other combinations. For example, when I change the arrangement to 4 times 6 times 5, I notice that 4 times 6 can be grouped to equal 24, which can be matched to the expression 5 times 24. Sometimes we aren't given an image to work with, so we have to read problems carefully, underlining the math language that we recognize. In this problem, we are told to find the volume of a rectangular prism. It provides the length, width, and height. So I know to use the formula for volume of a rectangular prism, length times width times height. Since the dimensions are given in units, I have to make sure to label the quantity for volume as cubic units. The next rectangular prism has a base of 200 square inches and a height of 6 inches. I know that the base is two dimensions already combined, in this case the length and width, so I just have to multiply the base times the height. Since the dimensions are given in inches, I have to label the volume in cubic inches. This is another problem where we have to find the volume of a figure. I start by dividing the figure into two rectangular prisms since I know the formula for finding the volume of prisms. I label them A and B. I then begin organizing my information by writing the same formula for both prism A and B, length times width times height. I now go about finding the dimensions for prism A. The length of A is labeled along the horizontal line, the width along the diagonal, and the height is labeled along the vertical. When looking at prism B, the measurements for some of the dimensions might not be as obvious. For example, at the bottom of the figure, you see a label for the length. But because we're looking for the length for only prism B, we can't use this measurement. Instead, we need to use the measurement labeled on the top horizontal line as the length for B. And the height is 2 feet. Now that we have the dimensions for both prism A and prism B, we can begin our calculations. Once we've multiplied the length, width, and height for each prism, we add the volumes together to determine the total volume of the figure. This problem asks us to find which statement describes the volume of the rectangular prism in cubic units. I notice that the base layer of the prism has 6 cubic units, plus 1 on top, equaling a total of 7 cubic units. However, these units do not fill the rectangular prism, which we were directed to find the volume for. I can use the shown cubic units to guide me in finding the volume of the prism. For example, there are 2 units along the length, 3 along the width, and 2 along the height. If I use the formula length times width times height, I can see that I can fit 12 cubic units in the prism. I know that the volume must be at least 12 cubic units, not less than, since 12 can fit. But I also see a gap at the top, which means that while 12 do fit, that is not the exact volume because 12 cubes do not fill the prism completely. The volume, therefore, is greater than 12 cubic units. In this problem, my class is designing a garden box that is made of 2 rectangular prisms. To better understand a problem like this one, it is important to visualize what this might look like. Although it is not necessary for you to do this, as it might pose a challenge, I drew a garden box made of 2 rectangular prisms to help you envision what it might look like. The problem goes on to tell us that the garden needs to have a total area of at least 200 square feet for the plants. I know that in math, area refers to a flat surface that is measured in square units. Each face of a rectangular prism is a flat surface. But since plants grow from the top of a garden box, I realize that this is the flat face, or base, that measures 200 square feet. I can help you visualize this by drawing plants at the top of the garden box. I will now draw the base from a bird's eye point of view, which looks like 2 flat rectangles from above. I will make a note of the important information from the text, that the total area of this rectangular base is 200 square feet. The problem asks me to find possibilities for the length and width of the base of each prism. I remember that I can find the area of a rectangle by multiplying its length and width, so I need to determine an area for each rectangle first. Since the total area is 200, I have decided to make rectangle a 100 square feet, and rectangle be 100 square feet, which totals 200. Now I need to think of factor combinations that when multiplied equal 100. For example, 10 times 10 equals 100. 25 times 4 equals 100. 50 times 2 equals 100. And 20 times 5 equals 100. And now I have to choose a set of factors to represent the length and width for the first rectangle, so I choose 50 as the width and 2 as the length. And now I need to choose another set of factors for the second rectangle. I could do 50 and 2 again, but instead choose to use 25 as the length and 4 as the width. I now want to make it clear that I've completed the task the problem directed me to solve. I will write out the length and width for each rectangle that makes up the base area of 200 square feet. The second part of the problem tells me that the soil volume needs to be less than 500 cubic feet. I want to make a note of this important information. I also want to make a note of what I know about measuring volume of a rectangular prism. Since the first part of the problem tells me that the base of the garden box is 200 square feet, I know that I can refer to the formula, volume equals base times height. I can use what I know from the text of the problem to determine a height that makes sense. I know the base is 200 square feet. This base needs to be multiplied by a number to make a product less than 500, since the volume needs to be less than 500 cubic feet. So I decide to make the height 2 feet. The height, 2, times the base, 200, gives a volume of 400 cubic feet. This fits the requirements of the problem. 400 cubic feet is less than 500 cubic feet, so making the height 2 feet is a sensible solution. I now want to ensure that I clearly respond to the task. I will make a note that the height I have chosen to use is 2 feet. By doing so, I will have completed the task.